Hi, and we're back. And in this video, I'm going to change the intervals for both the moving averages. We'll do two for loops to iterate over some values from like 2 to 20. And kick out the results to a CSV file to find out which of those two intervals is best, gives us the best weighted precision. To speed things up, we're going to change the test phase or the evaluation phase, and we'll use our own test instances. So we'll split the ARF file that we have now into data before January 1st, 2017. That'll be the training data. And the test data will be everything from January 1st, 2017 on. Also, because of the, if you remember in the code, we had these a little routine to shift the data from the output from TA-lib's SMA, or slow moving average function. TA-lib puts it in position 0. We wanted to line it up at the data level, or at the position that matches the data of the current price and the next day price, or the next 5 days out, whatever we are looking at. So we'll have to change that code just a little bit. Again, we'll call the random forest classifier and pass it to training instances. It will build our evaluation using the test instances of the ARF data. Kick out this data to a CSV file. The CSV file eventually will look at it through a spreadsheet and define the two best intervals. So I'm just going to show you the code after it's been written and quickly step through it. Alright, so we're back over into the Eclipse environment. And this is the finished Java program. I had renamed the class and the source code. No big deal there. We're still doing a 5-day ahead look ahead. And the first thing I did was I pulled out the header information for the ARF file because it's static and it'll be reused over and over again. Simply loaded that into a string writer, changed the print writer name, and I stored it. So you'll see we'll be using that over and over. Here we are reading the CSV file we downloaded from Yahoo. I added a dates array list so that we can split the data between the training and testing instances, and so we'll just as we read through the file, we will let's see, the dates is the first one, so there it is there. We just add the first parsed out string, which was the date in the CSV file, and was stored into dates. Moving the dates into an array for the TA-lib here. Calling the TA-lib core. We added a new output file called spyresults.csv. This will contain the moving average iterations, or interval values, along with the precision weight. We start off by looping through the fast moving averages. We're going to just do it from 2 through 9. Create those two objects required by TA-lib and call the moving average for fast and storing it in the fast array. Again, don't forget to move the offset. Everything from in the output array, SMA fast, starts at 0, but our input is at whatever the fast interval is. It starts off at the fast interval, so we just move everything to that position. Next, we do the slow, which is pretty much the same, but at the same time, let's we build the training and the test iteration string, or ARF strings. And we will output the headers to those two objects. Initialize the TA-lib objects used for the moving average. And quickly we see that we do slow. The slow interval will be from the 1 plus fast, and we'll do it through 20. Call the moving average function. Move the data so it aligns, and then we go through the loop to print the actual ARF data. And here's where we use that dates array list based on the position within the array. If we compare it to the first 4 characters to 2017. If it's less than that, then obviously it's the dates before 2017. And we write it to the training arf string. Everything after 2016, 12, 31, we will write it out to the test arf string. Pretty simple. We flush the file so that everything is filled in. We build our training instances on the training string. Set the class index again so that it uses the very last attribute to classify against. Call the random forest classifier to initialize it, and we load it with the training instances. Next, we take the test data and we load that into an instances object, again setting the class index. We call the evaluation with our training instances, but we evaluate it with our test instances. Finally, we will output it to the console, but more importantly, output it to our results CSV file, the fast value, the slow value, and the weighted precision value from the evaluation of the test data. So that's the whole loop, and it closes off. We will flush the file so that it keeps current, and then we close it. And we just simply run it. There's our log4j warnings. We don't really care about it. Now we're kicking out this is out to the console, and these are, again, this is the fast, this is the slow, and this is the precision weight. This takes a while, so we'll stop it right here and pick up after it finishes completion. Okay, so it's finishing up here. As you can see, it took about 4 or 5 minutes to run. It's terminated. Let's do a refresh on our project. And there's our SPY results CSV. Let's open that with the spreadsheet program. Okay, so OpenOffice wants us to import the text file, and then we will have it here. Here's our fast moving average interval, our slow moving average interval, and the outcome result, which is the weighted percentage of weighted precision. We want a high weighted precision, so let's sort this on column C, descending. And the best one we get is a very fast moving average of interval of 3 and a slow of 17. Same, next two are the same, along with fast moving average of 2 has a bunch also. So when we run the prediction program next, we will use the value of 3 for fast and 17 for slow. Now let's go back over to Eclipse and do the same thing for the SMO regression process using a numeric classification. Back in Eclipse, to quickly go through this, I've already written the program. Finding best SMO regression by changing the moving average intervals. It's pretty much the same as the last program. Again, our classification will be numeric, and the results to our R file will be written out with simply the value of the close, in this case 5 days ahead. Everything before 2017 is written to the train ARF. Everything else is written to the test ARF. And there's our call to SMO regression. Build the instances just like everything's the same. We evaluate the model using the classifier and the test instances. In this case, we'll be kicking out the root mean square from the evaluation. Let's run that. And if you remember, this is very slow, so we'll come back after a word from our sponsors. Alright, the program is completed. Let's take a look at our SPI results for a numeric classification. And as you can see, the mean squared error really doesn't change too much over the values of the interval values. We'll just do a quick sort on column C, descending or ascending, and we can see the best two intervals are too short and 18, or too fast and 18 short or slow. So in the next video we'll run predictions for an SMO regression using a fast of 2 and a slow of 18, and the nominal by cell classification with a random forest with 2 and 18 also. Until then, if you like what you see, hit the like button.